Beautiful. All right, you guys, we're going to start off like we always do by going over our DMR that you should have completed yesterday. So you can see that the first one is your name. Hopefully you know your name. Hopefully you know how to write it. Hopefully you did write it. Remember on your quiz tomorrow, if you don't write your name, you get a 0% F because I can't give you credit because I don't know who you are. So make sure you put your name there, okay? Second question, complete the fraction with the missing numerator or denominator that matches the model. This is a 1, and it is talking about the one green piece. We are to find the denominator, which is the whole amount, and there are 1, 2, 3, 4, 5, 6, 7, 8. So you should have typed an 8. 8 is the missing denominator in this fraction because the bottom number shows us how many are in the whole. The next one, going down, 3. Which part of the fraction is missing? We already answered this. It's the denominator because that's the bottom number. And if I didn't know that, it's a good thing we took notes in our trusty dusty notebook. Right there, denominator, bottom number. And if you didn't take the notes, it's a good thing you have a teacher that loves you and puts it up on your seesaw for you. How about that? All right. Questions about these, why it is 8 or why it is a denominator. Any questions? No questions. All righty, we shall move forward. Next up, name the unit fraction shown in the model. Remember, unit fraction is the name of one piece. There are 1, 2, 3, 4, 5, 6 pieces. So one of them would be called 1/6. 1 out of 6 pieces. Okay, questions on that one? All right, we're feeling good. Next up, how many unit fractions make up the colored portion of this shape? There are 1, 2, 3. 3 of the pieces are colored, so 3 unit fractions make up the shape. There are 3 1/6 pieces. 1/6 plus 1/6 plus 1/6 equals 3/6. So there are 3. Questions, concerns, comments? No, we're feeling good. All right, your quiz is tomorrow. 6, find the area of the rectangle, also a square. The area is the length times the width. This time they're the same. 5 times 5 is equal to 5, 10, 15, 20, 25. And we have inches as our label. And those inches are squares because we are going up and down and left and right. So it makes a square. So you should have selected 25 inches squared. Questions, concerns, comments? All right. Next one is the same image of a square with 5 inches on the length and 5 inches in the width. But our perimeter is asking for the total distance around the shape. So we have to add 2 of the lengths, which is the bottom and the top. And we have to add 2 of the widths, which is the left and the right. So our equation is 5 plus 5 plus 5 plus 5. 5 plus 5 is 10, plus another 5 plus 5 is 10. 10 plus 10 is 20. So our answer is 20. Our label is inches. They are not squared because it is just going around one side, which is the outside. It is not going inside of the area, okay? 20 inches squared, or 20 inches, boom. Questions? All right, on we go to the last one. Think about it. If each star in this group is 1/8 of the total group, what fraction of the group is circled? Well, this would be 1/8, this would be 1/8, this would be 1/8, and this would be 1/8. There are 4 of those, so 4/8 would be the fraction. Some of you chose 4. 4 isn't a fraction. The question says fraction. So the fraction is 4/8, 4 out of 8. Questions, concerns, comments? All right. Tomorrow, your DMR quiz will unlock to you at 12:45. You have your DMR today as your last practice, and it will be an automatic review when you click on See Correct Answers after turning it in, okay? All right, loves. We are getting ready to move on to working with fractions again, but today we're going to look at fractions that are bigger than 1 on a number line, okay? So what happens when the fraction is bigger than 1? That would mean what happens when we're measuring on a ruler, and I thought I had my ruler. Apparently I do not. When we're measuring on a ruler and it's bigger than 1 of those inches, we got to go past the 1 inch, okay? Or when we're measuring for a new couch and we want to see how big it is, it's going to be bigger than 1 foot. So we're going to be adding to larger than 1 on a number line, okay? Here is your goal for the day.
We are learning about fractions. Our target this week is understanding the whole can be partitioned into equal parts. Today, we are going to represent fractions by using number lines. We will use our knowledge of the unit fraction to help us, and we will make sure we partition into equal parts. Sometimes we have a fraction that's greater than 1 whole. Today we're going to model fractions greater than 1 using a number line.
All right, so when our fraction is bigger than 1, what happens? Before we get there, I would like to go over fractions on a number line with that song that you guys love so much. This song really does help you remember these steps that we took notes on yesterday on how to write fractions on a number line. This is a song, which is another way that our brains can learn. So think about what is being shared, and then we will get started with some action.
My friend if she could help me find where to write 1/2 on the number line. She said,
first draw a line with 2 arrows.
Then she sang a song, here's how it goes. 0 to 1 is the whole that we split apart. The denominator tells us into how many parts. Make a line that starts from 0 to the first mark, and 1/2 is what you'll find when you get that far. My stuffed animal can't talk, but I thought I heard,
hey Ben, on the number line, where's 1/3?
I said first draw a line with 2 arrows, and hey, I know a cool tune, here's how it goes. 0 to 1 is the whole that we split apart. The denominator tells us into how many parts. Make a line that starts from 0 to the first mark, and 1/3 is what you'll find when you get that far. Then I texted my friend, what's to be done when the numerator isn't 1? She said,
let's try to find 5 over 9 on the number line in like no time. Simply partition 9 parts from 0 to 1. Starting from 0, count 5, and at 5 9ths we arrive.
0 to 1 is the whole that we split apart. The denominator tells us into how many parts. Make a line that starts from 0 to the 5th mark. And 5 ninths is what you'll find when you get that far.
Let's use the number line to describe this pie. First count the total pieces, there are 5. 5's the denominator, all the parts, so 5 goes underneath the fraction bar. This number line goes from 0 to 2, but the fraction's less than 1, so here's what to do. Make 5 equal spaces from 0 to 1. Now the final step before we're done. The numerator is the one piece that's mine. After the first space, I'll write 1/5 of the line. Just remember this one tip in your minds. Always count the spaces, never the lines.
0 to 1 is the whole that we split apart. The denominator tells us into how many parts. Make a line that starts from 0 to the 1st mark. And 1/5 is what you'll find when you get that far.
When you get that far, yeah. When you get that far, yeah. Haha.
I practiced that dance all night for you guys, so you're welcome. All righty, there we go. We have watched our video. Now we're going to take a look at what happens when that denominator has a whole that is bigger than 1. What's going to happen when we have to make something bigger than 1 inch or 1 foot or 1 meter or 1 mile or 1 anything? One of Josh's fingers, right? He's going to measure things in 2 fingers or 3 fingers, right? Okay, we're going to figure out what happens. Place 5/3 on the number line. 5/3? How can I have 5/3 if there's only 3 in a whole? Let's find out. Here we go.
Today we are focused on fractions that are more than 1 whole or greater than 1. This example asks us to place 5/3 on the number line. When dealing with fractions that are greater than 1, the first thing we need to do is identify the whole. I notice my first tick mark is 0, and 1 whole is right here. This space between 0 and 1 is 1 whole. If I continue on the number line, I notice my next tick mark is 2. The space between 1 and 2 is another 1 whole. Our job is to place 5/3 on the number line. So I'm going to focus on the fraction I'm given, and I'm going to start with the denominator. My fraction is 5/3. I know the denominator tells me how many equal parts are in the whole. So when I look at my first 1 whole, I can imagine that there are 3 equal parts. If I skip count from 0 and think about my unit fraction, I know that each space will be 1/3. 1/3 plus 1/3 plus 1/3 equals 1 whole. 3 1/3 is the same thing as 1 whole.
So you will notice that there are not 3 parts on this entire number line. There are 3 parts on the 1 whole, okay? We're going to talk about how to deal with this second part of the number line here next. But first, we have to figure out how many parts are on the whole. Our denominator told us 3, so we created 3 parts from 0 to 1 is the whole that we split apart. So we start with the 3, okay? Don't laugh at me, Camille. You love that song. You know it's beautiful. You love my voice. Here we go.
Our tasks asks us to put 5/3 on the number line. Right now, at the 1 mark, I'm at 3/1/3. Next, I can partition my second whole into 3 equal parts. I'm going to use the line tool to partition. I now have partitioned my whole into 3 equal parts. I know that at the 1 mark, right here, that is 3/1/3. So next, I will continue on and keep counting each 1/3. 1/1/3, 2/1/3, 3/1/3, keep going. 4/1/3, 5/1/3. I can place a point and label 5/3, which is the same thing as 5/1/3. Remember to count the spaces between the tick marks, not the lines that you have partitioned with.
Okay, so let's get some practice in, kiddos. Please go onto your Seesaw. And I'm going to send, yeah, one of y'all does this every day. Goober John, I'm going to send this back to you. It says do it with your teacher. We haven't even started yet. There you go, John. You got it back. All right. You are going to click on the lesson 12-5, fractions greater than 1 on a number line. Okay. We have looked at the teaching videos. I'm going to save this textbook video for us. So now it says complete slides 1 through 6 with your teacher. Click on that add response. So remember, I suggest that when you add your response, you make your screen half size like this so that you can see your work. And then over here, you can put zoom so that you can see my work. Okay, so split your screen so you can see your work and my work at the same time, because we're going to work on these sections together. All right. Slide 1 says with your teacher. That's me. So we're going to work on these together. Take a look at slide 2. This is an example. This says a bunny hopped 7/4 of the distance of a trail. How can you show this on a number line? So here is the trail and here is our bunny. The trail is 2, let's call it miles, 2 miles. The bunny did not hop all the way to 2 miles, but they did hop 7/4 of the way there. We know that the whole is the distance between 0 to 1 is the whole that we split apart, right there. And the denominator is 4. Because the denominator tells us into how many parts. Divide the whole into 4 equal lengths. That's what they did. Here's 1, 2, 3, 4 at 1 whole. Each length is 1/4 of the whole. Then we can see that the bunny hopped 7 of them. 1, 2, 3, 4, 5, 6, 7. So that is 7/4 right here. And it is after 1, so we can see that 7/4 is greater than 1. Okay? You did not need to write this. I should have said that. This is just an example. I'm just illustrating for you. Okay? Let's take a look at 3. This is where you are going to write. It says follow along with your teacher. So if I write, you need to write. In 10 and 11, use the number line below. Here's the number line. I'm noticing that there are locations on the number line. It looks like 0 is where we start, and we start at school. At 3-6 is a grocery store. At 5-6 is a post office. Then we have 1 whole mile. And after 1 mile is the swimming pool. So the swimming pool is greater than, more than 1 mile from the school. Okay, let's look at number 10. What fraction, that's important, underline it. What fraction tells how far the swimming pool is from the school? Explain how you know. So we've got to do 2 things. We've got to write the fraction. We've got to explain. Okay, so let's take a look. We have 0, 1-6, 2-6, 3-6, 4-6, 5-6. 1 whole is the same thing as 6-6. Let's write that. 6-6. We've just gone in order. 1-6, 2-6, 3-6, 4-6, 5-6, and here's 1 whole, which is the same as 6-6. All right, guys, finish the pattern. 1, 2, 3, 4, 5, 6, 7. This is 7-6. Go ahead and write that. So it just follows in order. 1-6, 2-6, 3-6, 4-6, 5-6, 6-6, 7-6. So where is the swimming pool? The swimming pool is at 7-6. That is my fraction that shows where the swimming pool is. We were told to explain. I don't want to write with my finger, so I'm going to add a text box. So the way that I will explain is the pool is after 1 hole. Yeah, I just saw you encouraging me. Thank you. The pool is after 1 hole. 7-6 is after 6-6. And that's our explanation. So the pool is after 1 hole. 7-6 is after 6-6. That's how we know that it is bigger, that numerator is larger than the denominator. Any questions on that one? Okay, let's take a look at number 11. Higher order thinking. The hospital is halfway between the grocery store and the post office. What fraction tells how far the hospital is from the school? There's some important information here. Let's highlight it. Halfway between the grocery store and the post office. We're looking for a fraction and we have to explain. Okay? Get a pen ready. I'm going to change it to black so that I can see it easily. It says halfway between the grocery store. I'm going to make a big line where the grocery store is. And the post office. I'm going to make a big line where the post office is. We know that when we split something in half, we have to cut it in the middle. What is in the middle of the grocery store and the post office? Boom. 4/6. That's right in the middle or in half of the grocery store and the post office. So what fraction tells how far the hospital is from the school? The school's back here. It is 1, 2, 3, 4, 6 from the school. So what fraction? The fraction is 4/6. We're also asked to explain. So we have to explain how we figured that out. So I'm going to add a text box because again, it's a lot of writing. So I find it easier to type than I do to write with my finger or my mouse. Actually, I'm going to erase that. Halfway between 5/6 and let's switch that 3/6. Halfway between 3/6 and 5/6 is 4/6. And we know that because we know how to count by ones. If I say what's between 3 and 5, you can go 1, 2, 3, 4, 5 and figure that out. So halfway is between 3/6 and 5/6 is 4/6. Questions on that one? Remembering that copying does not equal learning. Understanding what you are writing equals learning. So what questions are there about what you've just written down? Okay. Go to slide 4, please. Click on slide 4. Slide 4 says, follow along with your teacher. Here we have some blanks. We are going to write the fractions that are missing in the blanks. Let's start with 0 to 1 is the whole that we split apart. So here's 0 and here's 1. Let's count how many spaces or pieces are there. 1, 2, 3. Look, that matches my denominator. 3. That tells me I'm working with thirds. So I have 0, blank, 2/3, 3/3, blank. Well, let's figure out what's missing. 0, 1. 1 comes after 0. So 0/3, 1/3, 2/3, 3/3. Hold up with your fingers. How many is the next one? Show me on the camera. How many thirds? I'm glad 4 of you are listening. More of you, more of you, more of you. Excellent. 4/3. 1/3, 2/3, 3/3, 4/3. That is what is missing. So fractions, when they're on a number line, guys, is really just counting 1, 2, 3, 4, 5, 6 until you're done with the number line. It's just counting with the addition of a denominator, a number that stays the same underneath. William, yes, sir.
You gave it away when you said 4, guys.
I did. You're smart. You're catching on. Other questions? All right. Let's take a look at slide 5. Follow along with your teacher. Quinn, that's the name of Mr. Kemper's daughter. Quinn says that 10/8 comes to the right of 9/8 on a number line. Do you agree? Why or why not? All right, let's draw a number line. 0 to 1 is the whole that we split apart. The denominator tells us into how many parts. Y'all didn't know I could get that low, did you? I got mad tricks up my sleeve. All right. What happens as we move to the right? Do the numbers get larger or smaller as we go to the right? Show me with your fingers. Larger, point up. Smaller, point down. What happens as we move to the right, as we move this way? What happens? Good. We're moving on up. Moving on up. Yes, we're going up. Okay, so would 10/8 come to the right or after 9/8? Yes. Okay, it would because the numbers get larger. So we're going to explain if we agree. So yes, and then I'm going to move this text box so I can see. Yes, I agree. Levin, a question.
Can I please go to the bathroom real quick?
Yes. Yes, I agree. Because, that's that explanation word. We got to have because in there if we've been asked why. Because numbers get larger as you move to the right on a number line. It's just common sense. They're just checking to make sure you got it. Okay? So yes, we agree because we know that numbers move larger, greater, bigger as we move to the right of a number line. And 10/8 is bigger than 9/8. So you are actively typing this in the chat. I don't know why I'm having a lot of people turning their videos off. Videos are on, just like your eyes are open at school. All right. Questions about this one? Okay. I want you to notice with this picture that I drew here, I didn't fill out the whole picture because I didn't need to. It didn't even ask me to draw a picture. I just wanted to work it out in my head, in my brain, to see if it made sense. So I just drew myself kind of something to help me see and think. Okay, that's a great strategy for you to use. Feel free to draw an example anytime your brain needs to see it worked out. Okay? All right. Slide 6 is going to be completed in your breakout room. So look at slide 6. In your breakout room, write the missing fractions in the blanks. You are going to complete numbers 1 and 2 in your breakout room. So talk with each other about what fractions are missing. I want to remind you to look from 0 to 1 because it's the whole that we split apart. And that denominator tells you into how many parts. Okay, so take a look at that whole. Take a look at that denominator before you and your breakout room start working. Okay, all right, let me get these set up and then we will look at the correct answers when you get back. Okay, you were asked in breakout rooms to solve problems 1 and 2 on slide 6. Here's the correct answer. This is the conversation that I had with a couple people in the breakout rooms. A lot of you guys forgot that 1 whole is the same thing as 6, 6. A lot of breakout rooms were putting 6, 6 right here, and that's not true. And let me show you another really easy way to figure it out. 1, 2, 3, 4, 5, 6, 7, not 6. Same thing if I were to do hops. 1, 2, 3, 4, 5, 6, 7. Okay. You guys got to remember that 1 whole is the same thing as 6 sixths. Okay. So the correct answers that you should have written are in orange. 1 6, 2 6, 3 6, 4 6, 5 6, 6 6, 7 6, 8 6. Okay, there's that imaginary 6 6 that is the same thing as 1 whole right there. Okay, here is your correct answers for number 2. Remember, the denominator tells you into how many parts. Look at the denominator right there. Boom, 2. It's a 2. So guess what your denominator has to be here? A 2. And that is because there are 2. 1 piece, 2 pieces between 0 and 1. Because 0 to 1 is the whole that we split apart. The denominator tells us into how many parts. And there are 2. 1, 2. Okay? So we went from 0 halves to 1 half. 1 whole is the same thing as 2 halves. And then we have a 3 halves. Okay? Got it? All right. William, not yet. Oh, I didn't mean to erase that. I just wanted to erase my extra notes. There we go. Okay, questions, concerns, comments about these number lines. Remember, copying does not make your brain learn. Understanding makes your brain learn. I want questions. Questions are good. Questions give me my job. Questions make me happy. Okay. Your work is going to be on the rest of the slides. Slide 7 says independently for a grade. You are going to complete 4 slides today for a grade. Slides 8, 9, 10, and 11. I want to remind you to look at the denominator tells you into how many parts. Look at that denominator. Look at that denominator. Look at that denominator. Look at that denominator. Look at those, okay? Denominators are going to help you. As always, on slide 12, you need to drag the emoji that best describes your feelings, and you need to say why. Remember to use math vocabulary. It was easy. Easy is not in this vocab list. Okay, I did it perfect. Perfect is not in this vocab list. Use vocabulary words to explain how you know you were successful or how you need help. Okay? All right, so this is your independent work for the day today. And I will stop the recording now.